Vertex form is what you do. Well, it's an easier way to graph quadratics. And this right here is vertex form. Okay? So if you want to color this in your fifth color or whatever, this is only color in the signs. So color in the equals, color in the parentheses, the squared, and the plus. Use your fifth color for this one. Or your pencil if you didn't get a fifth color. Now the reason is, each of our letters is going to have a different color because each of our letters do different things. And vertex form is taking the parent function and moving it around. And what was our parent function? Who remembers? Y equals x squared. Take a point. Are we ready? Okay. So A is the number out front. And this A right here, it tells us what happens. So the absolute value of A, which means no matter what the number is, take the absolute value of it. And if it's greater than 1, it's a narrow graph. That means it stretches it, right? We've talked about that before. If we have a fraction, if it's less than 1, that makes it a wide graph. And if it's less than 0, it's inverted, which means that our graph looks like this. Can y'all see that, or do I need to darken it? Yes? Okay. So inverted means it turns it upside down. So this number out front controls whether it stretches, whether it goes wide, or whether it turns upside down. So if it's positive, does our graph ever turn upside down? No. It only turns upside down if it's what? Negative. Awesome. All right, now let's look at our x. X are the numbers that we input, which is also known as our... I just said the word input. So what's the other word? Domain. Take a point. All right, what's Y? Output or your range. Take another point. And X and Y are what are the coordinates. It's what we plug in and what we get out. So what we're doing is we're going through and finding out what does each letter do to the graph. Well, that's what we're finding out. Now, H and K are very special. In vertex form, H and K represent the vertex. H, does it come first or second? First. So that means that it's the X value of your vertex. All right, so let's color that. Whatever color you want, mine's going to be this pretty purple. All right, now H down here. It says that if it's a minus, that means that H is positive because your vertex form is X minus H. So you take the number out, whatever it is. If it's a minus, that means it's positive, so it moves it to the right. If it's plus, that means it's a negative, so it moves it to the left. On which axis? It's the first letter, so it's the X axis. And plus, left and right is on the X axis. Bless you. We ready? Do we need a mow? What's happening? Oh, we did need 5 colors. I need 6. Take it up. One day I'll know how to count. All right, so K is our final one. If H is our X, then K is our Y. Take a point. Ooh, that is a pretty color. A darker one, not a lighter one. Thank you for making sure I'm not crazy. Alright, so if H moves it left or right, what does K do?
Move it up or down.
Move it up, so yes. Moves it up or down. My words are not working today. If it's positive, how is it going to move it?
Up.
Up. And if it's negative, it's going to move it?
Down.
Fantastic. And this is vertex form. So you use H and K to get your vertex, move it around, and then we'll use our perfect squares. Remember how before we went up 1, right 1? And then we went up 4, right 2? And up 9, right 3? And then we did the same thing on the left? We're going to do the same thing today. You're not beating on your vertex. It's awesome. I need my water so I can actually get my words out for y'all.
It's okay. The more you struggle, the more time you take out.
Are we ready? Alright, so this is vertex form, and let's look at our example. Example 1, it says y equals x minus 6 quantity squared minus 2. Now, tell me what h is in this problem.
L. I can't see it. Oh, wait.
6, because you take the opposite. So 6 is our x value, and is it going to move it to the left or to the right? To the right, because it's positive.
No, it's negative.
Right. You take the opposite of what's in here, just like we did over here. Yeah, see? You see how we have an example right beside it? Ham sandwich. So it goes to the right, 6. And then what's our y value? Negative what? Negative 2. So we're going to go right 6, down 2, and that's our vertex. Ta-da! They told us right here. Alright, now on this one, what is going to happen after we plot our vertex? What does this number right here do? We're not going to distribute. It's this front number. What is this in the position of in our vertex form? Oh, you guys can't see where I'm pointing. Sorry. This number right here. Look at your vertex form at the top.
A.
It's A. Thank you. Take a point. And what does A do to the graph?
It widens it or inverts it.
It makes it wider, it stretches, or it inverts it. Now, is this going to make it wider, stretch, or invert? Okay, guys. This is a 2, right?
Yeah.
Okay. Let's go up here.
No.
Is 2 greater than 1? So what's it going to do?
Narrower.
Narrower.
Is that a word? Narrower?
Yes.
Definitely is a word.
Okay. Are we? I don't even. Alright. Go to this page. So first what we're going to practice is just horizontal translation, which is H. We're going to find our vertex, then we're going to go up 1, right 1, up 1, right 1, up 1, right 1. Up 4, right 2, up 9, right 3. Alright, let's open our flapping. Now, the first one, you're going to do each graph in a different color. The number 1, what is that function called? It's got a special name? Parent function, take a point. And it's x squared. So what's our vertex on y equals x squared? Does it have anything beside it? Does it have anything in front of it? What's in front of x squared?
1.
A 1, but anything other than a 1? Do we have any other numbers? So then it's a 0, 0. So everybody put a dot at 0, 0. And then from there, what do? We use our perfect squares. So we're going to go up how many?
Up 1.
Up 1, right 1. Take a point. And do we also go to the left? Yes, because it's a U. And then what do we do after that?
Up 4.
Take another point. And do we also go to the left? Fantastic. And do we connect it in a U or a V? A U. And if you don't connect it in a U, I'm going to start counting off. Because some of you on your test did not make a U. Alright, so so now we're going to translate it on the horizontal, which means x or y. And this says x minus 3 quantity squared. So is that our h or our k? That's our h. And so you take the opposite of the sign. So what's the opposite of negative 3? Positive 3. Are we going to move it to the left or to the right? To the right, how many? 3. 1, 2, 3. And it stays on the x-axis because we did not move it up or down any. Do I need to use my markers instead of my colored pencils? Or y'all fine? I need to? Okay. I hate children. Gosh, dear. Alright, now, what am I going to do from this point besides Austin?
Wait, say again. What do you need to do? Okay.
Up how many?
You're going to go up one, right two? Up one, left one.
Up 1, right 1. Thank you, Allie. Take a point. Do I also go up 1 and left 1?
Yes.
Look at us go. And then what do I do from here? Besides Allie and Austin. Take a point. Do I also go to the left?
Yes.
Ta-da! So how did the minus 3 shift it? Over to the right. How many units?
3.
Fantastic. Alright, let's graph x plus 2 quantity squared. How is that one going to move? What is my h this time?
It's going to move to the left.
Left how many units? 2. And how do we know to move it to the left?
Plus.
Because it's a negative 2. So you take the opposite and you go left 2. Now, am I going left 2 from this graph or from my parent function? From your parent function. And I go left 2. Do I go up or down any or just put a dot?
Put a dot.
Just put a dot. And then, besides Allie and Austin and the person who answered the last time, but you whispered it so I couldn't really hear it, was a female, tell me what to do.
This time you go.
Up 1, right 1. Take a point. Do I also go up 1, left 1?
Yes.
Okay. And then what do I do?
We go up one, right one.
Alright, so how did the plus 2 move our parent function? Moved it left how many units?
2.
Take a point. Alright, graph the last one without me. Use a different color. Are we done or do we need a mo? A mo? Okay. Can it be a rapido mo? Are you even on the right page?
Yeah.
No. I'm not talking.
And you can put your ball this one.
Does it look like mine? Yay! So we went right 1, and then up 1, right 1, up 1, left 1, up 4, right 2, up 4, left 2. Cool. Let's do a vertical translation. What does it mean by vertical?
Be up and down.
Up and down. Take a point. All right, and my K on the front was my pink color. All right, so K. It says when K is positive, the graph shifts where? Up how many units? Well, it depends on what K is, right? So it shifts up K units. When K is negative, how does it shift it? Down how many units? K units. All right, open the flappy. So first, again, we are going to graph our, what is number 1 called? Parent function. And where does the parent function start? Where's the vertex? 0, 0. Take a point. And after I plot 0, 0, what do I do? Someone from Hufflepuff tell me. Y'all are Hufflepuff. That's why I pointed over here. So after I plot my vertex, what do I do? We're going to have some confidence and we're going to say it out loud because we've done it 4 times. So tell me what to do. Up 1, right 1. Take a point. Do I also go up 1, left 1? What's that weird groaning? Stop that. All right, and then what do I do from there? Y'all, bow buttons. Not you. Manny.
Wait a minute. That's why we're figuring
He didn't hear you. Arriba 4.
And you go up how many?
Derecha 2.
All 4 right.
Look at you go. Take a point. And then do I connect it in a U or a V? A U. Must it be a U? Yes. Because a V is a different graph. Which we get to do after spring break?
I don't know. I try to make it look like a U, baby.
Persevere in the face of danger.
And then we're at the baby.
Hey, how you doing?
Let me go over that one more time.
Definitely not.
I'm so lost.
Is this a serious thing?
This is a serious. I
think it's work. He doesn't understand the up score.
What part are you lost on?
Because like I looked up, like I'm listening. I swear to God, on my life I'm listening. It's just going.
This is the parent function.
All right.
The vertex is at 0, 0.
All right.
I plot my vertex.
All right.
Then I use my perfect squares and I go up 1, right 1, up 1, left 1.
All right.
And then I go up 4, right 2, up 4, left 2.
Where did you get the fourth one?
Yeah, where'd you get that?
That's the next. Do we not know our perfect squares?
Wait, what? Yeah, well, where did you get perfect?
Shit, mentioned that.
It's a quadratic, and we've done that like,
Last like months.
yes.
Shit, mentioned that.
1,
It's been rolling.
4, 9, 16. And then when we go to the right, what's the square root of 1?
So, oh,
One.
one.
What's the square root of 4?
16.
What's the square root of...
Oh my God.
What's the square root of 9?
3.
What's the square root of 16?
Oh, I get that now. I thought you said.
So if our graph was bigger, we'd go up 9.
What you doing?
Dang, that makes sense, I guess. Kind of.
Okay.
Not really.
A month we've been doing this. Yeah. Doesn't it feel like it?
We were
Forever.
made.
Alright, let's do this one. Now, did they give us H or K this time? They give us K, and it's a positive K. So this says if when K is positive, the graph shifts up. How many units is it going to shift up this time? 1. So am I starting from the origin?
No.
So yeah,
the one above the origin.
And then you move up 1. So I start at the origin and I move up 1 is what I was asking. But I see our confusion.
I'm exaggerating.
And then
I need to tell what number. But I told a letter to give us. I need to.
You see how this is not inside the parentheses? That's K. Because we know what our vertex form is. You're welcome. Alright, and then from there, Kimberly, what do I do? And then, look at you go. Take a point. And I'll also go to the left. And then Manny, for the love of God, get this one right. What do I do after that?
Up one.
And then,
Oh, right two.
without someone whispering it to him. And take a point, Manny. Kimberly, did I give you a point? I did or didn't? I can't hear you because she's answering. Okay. All right.
So can you say you got 3?
Where I got 3 where, baby?
You went up 3 right one, and up 3 left one, or up 3.
It's 2, 4.
You start at your vertex.
Yeah, I know. I got the one part, but like.
And then they go up 1, right 1?
Yeah, but how'd you still? Like,
Oh my God.
yeah, where'd you get 16? Like, you know what I mean, right? Okay.
Huh?
I'm not see.
Do you know what our perfect squares are? 1, 4, 9, 16, 25, 36, 49. Okay. So you go up your perfect squares. And then you go left or right your counting numbers.
Oh, yeah, that makes sense.
We just said this.
Yeah, I was listening, but I wasn't like, taking it in.
He wasn't listening. That's what he said.
Right. All right, number 3. Did they give us H or K? They gave us K. Am I going to go up 2 or down 2? Down 2. And then Jackson, can you help us out and tell us what to do from the vertex?
We go up 1, left 1, then up 1, right 1.
Look at you go, sir. Take a point. Ashanti, can you tell me what I do after that?
Up one. Right one.
Right.
2.
2. Awesome. Take a point. And do I connect it with a U or a V? Dylan.
You.
Hallelujah. Take a point.
You said you were B.
Yes. What?
What's a necklaces?
Mm-hmm. All right, graph the last one without me.
You go down 4?
I can't tell you that.
Okay. I'll use the marker.
We got homework.
See. We won't have it tonight.
We don't have homework?
No, but we're not done with our lesson.
Right?
We have 3 minutes.
You go down for it, right? And then you go up left 1 and right 1, right? And you go up 4, then you go right 2, right? And then you grab on the other side, right? Boom, lesson done.
Did everybody get that? Yeah. All right, tomorrow we're going to do reflection dilation, and then we're going to do an activity, and then guess what it is? Spring break.
We don't have to see y'all for 2 weeks.
Only 1 week. Only 1 week you get to finish up.